I'm going to talk about a couple of ways to do this question. So, method one is to work out the area of the entire rectangle, which is going to be 63, and then minus the four triangles here. Now, it turns out that these four triangles have the same area. I mean, this one and this one are congruent, and the other two are congruent to each other, but not to the ones with blue dots. I'm going to explain why they will have the same area. So if I just look at this top one, then here I've got a base of 9, and then this, well, I can see that I've got 7 centimeters for the total height, and then because these are equally spaced, that means this here is going to be 2/7 of 7 centimeters. Because as I go, I'm going down by the same amount every time, basically. That's the only way they could be equally spaced. So that's how I know it's 2/7 of 7. So one triangle, or this top triangle, is therefore half times the base times this height. Now, if we just take a look at this triangle on the left, it's going to be a very sort of similar setup, but now we've got this. I call this the base, if you imagine turning it around, and this is 7. And now this is going to be 2/7 of 9. So I'm just timesing them in a different order, but I'll do a half times 7 times 2/7 times 9. It's exactly the same. And therefore, in total, the area is going to be 4. That is all the triangles. 4 times a half times 9 times 2/7 times 7. I can cancel out the 7s. I can actually cancel out the half and the 2, giving me 36 for the blue shaded area. And therefore the shaded region, the grey shaded region that is going to be 63 minus 36, which becomes 27 centimeters squared. It's quite a nice approach. Here's a second approach that the solutions give. I think this is a little bit harder to get your head around personally, but what we can do is draw lines from the bottom left and top right corner to each of these little marks, and then justify to ourselves that every single one of these triangles has the same area. And the reason is that we can consider this to be the base, for example, of this triangle here, but actually they're therefore all going to have the same base. And then I need to draw the perpendicular height. So that is going to be whatever length kind of takes us in line with this. Now imagine you have a triangle that looks like that. Then what I'm saying is you've got the base here, and actually your perpendicular height is this thing. And your area is still a half base times height. So as I draw in all these different bases and their perpendicular heights, they will always be in line with this, and therefore they will all be the same. It's just kind of hard to see to some extent. For example, this one, that this is the base, and then we're still doing the perpendicular height along here. But it is the case, and I've seen questions, especially on the intermediate maths challenge, that really use this idea, and you have to go with it. I avoided it with my first method, but hey, this is an alternative. So we're going to have the whole area is 63. And now I've got 14 triangles. So I can divide by 14 to work out the area of one triangle. But then I've got 6 of them that I actually want to find the area of. So I can cancel 63 is 7 times 9. So I can make that 9 here and 2 here. And I can cancel the 2 with the 6 partially, leaving me 9 times 3, which also gives 27. Well done.